Good day. Today we will be looking at Module 2 Analytical Geometry, lesson number 4, and we will specifically look at tangents to circles. First, we will look at lines and circles that intersect. For example, determine the coordinates of the points where the line x minus 7y equal to 25 and the circle x squared plus y squared equal to 25 intersect. In other words, we want the coordinates of this point as well as that point where the circle and the line intersect one another. Now, to find the coordinates of the points of intersection, we have to solve the two equations simultaneously. So if I take my straight line equation and I get the x alone, I will take the minus 7y to the right hand side and it will become a positive 7y. So therefore I can say that x is equal to 7y plus 25. Then I can take this x value and substitute it into the equation of my circle in order to solve y. So if I take my circle equation, x squared plus y squared equal to 25, I'm substituting the x with the 7y plus 25. Now I must just solve my equation. If I take my brackets squared and I simplify it, the 7 squared becomes 49 and the y must also be squared. Then 25 squared is equal to 625. Then you mustn't forget your middle term. To get that, I use my short method, 7y times 25 times 2 gives me 350y. The y squared stayed like that, and then I take my 25 on the right hand side to the left hand side and it becomes minus 25. Then I put my like terms together. 49y squared plus y squared is 50y squared. The 350y stays 350y. And when I simplify my constant values, 625 minus 25, I get the 600. Now I have a quadratic trinomial and therefore I must factorize. I can take out a 50 out of each term as a highest common factor, so therefore I will divide each term by 50. 50y squared divided by 50 is y squared. 350y divided by 50 is 7y. 600 divided by 50 is 12. And of course 0 divided by 50 remains 0. Now I can factorize my quadratic trinomial even further by putting them into two brackets. The y times y gives me the y squared. Factors of 12, 4 times 3 gives me 12. And then I must test my middle term. 4y plus 3y gives me the middle term of 7y. Now to solve y, I have to take each bracket separately and set it equal to 0. So if I take my y plus 4 equal to 0, the plus 4 to the right hand side becomes minus 4 and therefore y is equal to minus 4. If I take my second bracket and set it equal to 0, the plus 3 must go to the right hand side and it will become minus 3 and therefore y is equal to minus 3. Now I must also find the corresponding x values. Therefore I will take my two solutions and then substitute them into my original equation in order to get the corresponding x value. So if I take my x equal to 7y plus 25 and I substitute y with minus 4, I can simplify. 7 times minus 4 is minus 28 plus 25 gives me the x value of minus 3. The same then when I substitute y with minus 3. 7 times minus 3 is minus 21 plus 25 gives me a positive 4 and therefore x is equal to 4. So if I write it as the coordinates of the 2 points of intersection where y is minus 4 x is minus 3. And when y is minus 3, the corresponding x value is 4. We can now continue with example 2. The circle x squared plus y squared is equal to 65, and the line y plus x is equal to 3 intersect in A and B. Determine the coordinates of A and B. In other words, we have to solve simultaneously. And then question B, calculate the length of AB, and we must leave the answer in simplest surd form. So if I start with my straight line, y plus x equal to 3, and I get y alone on the left, I will take the plus x to the right hand side, and it will become a minus x. So my new equation is then y equal to minus x plus 3. This y value will then be substituted into my circle equation in order to solve x. So if I take my circle equation, x squared plus y squared equal to 65, I'm substituting the y value into my circle equation. I can then simplify my brackets, and a minus x being squared, a minus times a minus becomes a plus, x then squared. Then for my middle term, I use the short method. Minus x times 3 times 2 gives me minus 6x, and the 3 being squared, 3 times 3 gives me 9. The 65 is taken to the left hand side and it becomes minus 65, and this x squared remained x squared. Now I must put my like terms together, and the x squared plus x squared becomes 2x squared. The minus 6x didn't change, it stayed minus 6x, and then my constant values must also be put together. 9 minus 65 gives me minus 56. Now I have a quadratic trinomial equal to 0, and therefore I can factorize. I can take out a highest common factor from each term, namely 2. Therefore, if I divide by 2 in each term, I will have 2x squared divided by 2, which is x squared. Minus 6x divided by 2 gives me minus 3x, and minus 56 divided by 2 gives me minus 28. Now I can factorize my quadratic trinomial even further by putting them into two brackets. X times x gives me the x squared. Then the factors of minus 28 is minus 7 times 4, which gives me the 28. And I must test my middle term. Minus 7x plus 4x gives me minus 3x in the middle. To solve x, I have to take each bracket and set it equal to 0 separately. So if I take my x minus 7 and set it equal to 0, the minus 7 will go to the right hand side and become a positive 7. Therefore, x is equal to 7. If I take my bracket x plus 4 and set it equal to 0, the plus 4 taken to the right hand side becomes minus 4, and therefore x is equal to minus 4. But now I must still find the corresponding y values for each x value. Therefore, I will take my straight line equation, y equal to minus x plus 3, and substitute the x first with 7, and then I will substitute my x with minus 4. So here I have my straight line equation, y equal to minus x plus 3. If I make x equal to 7, minus 7 plus 3 gives me the corresponding y value of minus 4. If I take my straight line equation again and I substitute x with the minus 4, a minus times a minus becomes a plus 4, plus 3 gives me y equal to 7. So the coordinates are A, where x is 7, y is minus 4, and coordinate B, where x is minus 4, the corresponding y value is 7. Now for the B part of the question, we have to calculate the length of AB, and leave the answer in simplest surd form. This means that I have to use my distance formula, where I take the x of A minus the x of B, bracket squared, plus the y of A minus the y of B, and also the bracket squared. If I do my substitution, then I will take the 7 minus the minus 4, which becomes a plus 4, bracket squared, plus minus 4 minus the 7, and also bracket squared. I can now simplify. 7 plus 4 is 11. 11 squared is 121. Minus 4 minus 7 is minus 11. And minus 11 squared, the minus times the minus becomes a plus. 121, 11 times 11. If I now add the constant values, I get 242. And then the square root of 242 can be simplified as 11 square root 2. This brings us to the new part of the lesson, where we want to look at tangents to circles. Now, a tangent intersects a circle only in one point. A tangent is a line that touches the circle only in one point. Now, for the next examples, we are going to use the Euclidean geometry theorem that a tangent to a circle is always perpendicular to the radius drawn to the point of contact. So if I have my radius, the radius is perpendicular to the tangent. Example 1. Determine the equation of the tangent to the circle x squared plus y squared equal to 25 at the point P, where x is 4 and y is 3. The solution: in this circle, we know that the center is at the origin 0, 0. So we do have a coordinate at this point 0, 0. This means that we must first find the gradient of the radius, and the gradient OP can be expressed as y of P minus the y of O over the x of P minus the x of O. So if I do my substitution, I take the 3 minus 0 over 4 minus 0. If I then simplify, I have the gradient of the radius OP equal to 3 over 4. But now we know that the radius is perpendicular to the tangent. In other words, if I take the gradient of the radius and I multiply it by the gradient of the tangent, it has to be equal to minus 1. So therefore, I already have my gradient of the radius, 3 over 4, multiplied by the gradient of the tangent, and that must be equal to minus 1. So to work out the gradient of the tangent, I will take my minus 1 and divide it by the 3 over 4, and therefore the gradient of the tangent is equal to minus 4 over 3. Let's just revise the algebra. We said to get the gradient of the tangent alone, we have to divide the 3 over 4 into minus 1. That means if I change my division sign to a times, I have to toss my fraction and make it 4 over 3. Then my minus 1 times 4 is minus 4 over the 3. Now we have the gradient of the tangent, which means the tangent is a straight line, and the standard equation of a straight line is y equal to mx plus c. So I can substitute my m with my gradient that I've worked out, and then I must substitute this coordinate into the x and y values in order to solve c. So I write down my standard equation y equal to mx plus c. The gradient of the tangent was worked out being minus 4 over 3, so m is substituted with the minus 4 over 3. And then we have a coordinate P on the straight line where x is 4 and y is 3. Now if I solve it, the minus 4 over 3 times 4 becomes minus 16 over 3. If I take my minus 16 over 3 to the left hand side, it becomes a plus 16 over 3. And 3 plus 16 over 3 gives me the c value equal to 25 over 3. Now I must put my m and my c value back into my standard equation, and therefore I can say that the equation of the tangent is y equal to mx, the minus 4 over 3, x, plus the c value 25 over 3. Example 2. Show that y equal to 3x plus 10 is a tangent to the circle x squared plus y squared equal to 10. So the solution then will be where we have to solve the two equations simultaneously. If we get only one point of intersection, we know that it is a tangent. So first we will solve simultaneously. We'll take the y equal to 3x plus 10 and we will substitute this y value into the circle equation. If I then simplify my brackets, 3x being squared, 3x times 3x is 9x squared. Then for the middle term, I take the 3x times 10 times 2, which is 60x. 10 being squared, 10 times 10 gives me 100. The 10 on the right hand side taken to the left becomes a minus 10, and the x squared at the beginning stayed like that. Then I have to simplify my like terms. X squared plus 9x squared gives me 10x squared. 60x just remains 60x. And then the constant values, 100 minus 10 is 90. Now I have a quadratic trinomial equal to 0, and therefore I will first take out a highest common factor of 10 out of each term. Therefore, if I divide by 10, 10x squared divided by 10, I get x squared. 60x divided by 10 is 6x. 90 divided by 10 is 9. Now I can factorize further by making use of two brackets. X times x gives me the x squared. Factors of 9 is 3 times 3. And I test my middle term. 3x plus 3x gives me the middle term of 6x. Now in order to solve x, I have to take each bracket and set it equal to 0 separately. If I take my first bracket, x plus 3 equal to 0, the plus 3 will go to the right hand side and becomes minus 3. But since the brackets are exactly the same, they give exactly the same solution, and there's only one solution for x, x being equal to minus 3. Then I also want a corresponding y value, so I will take my x value and substitute it into my original equation to determine y. So if I take equation A, y equal to 3x plus 10, I substitute the x with minus 3. 3 times minus 3 is minus 9, plus 10 gives me y equal to 1. In other words, there's only one point of intersection where x is minus 3, y is 1. And therefore, the line is indeed a tangent. Now you might wonder, why do I substitute into the first equation and not into the second equation to find y? It doesn't really matter which equation you choose. I could have taken the x equal to minus 3 and substituted into my circle equation as well, and it will give me the same solution of y equal to 1. I just chose to use the first equation because it's a simpler equation with no squares. Another example, find the equation of the tangent to the circle x minus 2 bracket squared plus y plus 1 bracket squared equal to 25 at the point where x is 5 and y is 3. It is always simpler to understand the question by drawing a rough sketch. If I then draw a rough sketch of this circle, we know that the center will be at A, where x is 2 and y is minus 1. So I use my circle equation. I change the sign of the constant value, a plus 2, and I change the sign here as well for the corresponding y value of minus 1. We were also given a point of intersection where the tangent touches the circle at B, where x is 5 and y is 3. So step 1 is to first find the gradient of the radius. So if I want the gradient of radius AB, I will take the y of A minus the y of B over the x of A minus the x of B. So if I substitute minus 1 minus 3 over 2 minus 5. Then when I simplify, minus 1 minus 3 gives me minus 4, and 2 minus 5 is minus 3. The minus divided by a minus is a plus, so the gradient of the radius is then a positive 4 over 3. Now, in case you are wondering, why did I take y of A first minus y of B second? It doesn't matter. I can also do it the other way around, taking the y of B minus y of A over x of B minus x of A. It gives me exactly the same solution. 3 minus minus 1 becomes 3 plus 1, which is 4. And 5 minus 2 also give me 3. And therefore, it gives me the same solution for the gradient of the radius being a positive 4 over 3. Now I must keep in mind that my gradient of my radius is perpendicular to the gradient of the tangent, and therefore to find the gradient of the tangent, I will change the sign to a negative and I will toss the fraction being 3 over 4. So remember, for perpendicular lines, I have to say that the gradient of the radius times the gradient of the tangent must be equal to minus 1. So the gradient of the radius, 4 over 3, is multiplied by the gradient of the tangent being equal to minus 1. In other words, to find the gradient of the tangent, I have to do the opposite calculation and divide the 4 over 3 into the minus 1. So minus 1 divided by 4 over 3 is equal to minus 3 over 4. Short method, change the sign from a positive to a negative and toss the fraction 3 over 4. Now I can determine the equation of the tangent by using the standard equation of a straight line, y equal to mx plus c. I substitute m with the gradient which I've worked out for the tangent, minus 3 over 4. I also have a coordinate, a point of intersection with the circle, where x is 5 and y is 3. If I now simplify, the minus 3 over 4 multiplied by 5 gives me minus 15 over 4, which must be taken to the left-hand side and becomes a plus 15 over 4. So 3 plus 15 over 4 gives me the c value of 27 over 4. Now I have to use my standard equation. Again, substitute my gradient in the place of the m, minus 3 over 4, and substitute my c value, 27 over 4. So the equation of the tangent is y equal to minus 3 over 4x plus the c value, 27 over 4. That brings us to the last example of this lesson. The circle has D3, 1 as center and the radius is 5. Find the equation of the circle. Find the coordinates of A and B, the y-intercepts of the circle. Find the equation of the tangent to the circle at A. Then question D, find the equation of the tangent to the circle at B. and then find C, the intersection of the two tangents. So let's get back to question A, finding the equation of the circle. Remember, this circle does not have a center at the origin, but it has a center AB. So if I take my standard equation of a circle, x minus a bracket squared plus y minus b bracket squared equal to r squared, I can substitute my a value as well as my b value into my equation. So looking at the substitution, we said a is substituted with 3 and b is substituted with the 1. We were also given a radius of 5 and therefore r can be substituted with 5. If I then simplify my 5 squared, I get the r squared equal to 25. My conclusion then, that the equation of this circle with a center AB is x minus 3 bracket squared plus y minus 1 bracket squared equal to the r squared, which is 25. In question B, we must now find the coordinates of A and B, the y-intercepts of the circle, and therefore we will let x be equal to 0, because x at point A is 0 and x at point B is also equal to 0. So now I will take my equation of my circle, which I've already worked out, and I will substitute x with 0. 0 minus 3 is minus 3, and minus 3 squared is a positive 9. If I then simplify my bracket, the y must be squared. Then for the middle term, I take the two terms, multiply them by one another and times it by the exponent 2. So y times minus 1 times 2 gives me the minus 2y. Minus 1 squared means that minus 1 times minus 1 becomes a positive 1. The 25 on the right hand side must be taken to the left and therefore becomes a minus 25. Now I can put my like terms together. I already see that there's only one y squared. It stays like that. The minus 2y also stays like that. Then 9 plus 1 is 10, minus 25 is minus 15. Now I have a quadratic trinomial equal to 0, and therefore I can factorize it to solve y. Y times y gives me y squared. Then the factors are 15, 5 times 3 gives me the 15, and then I must test it for the middle term. Minus 5y plus 3y gives me the minus 2y in the middle. Now to solve y, I have to take each bracket and set it equal to 0 separately. Therefore, if I take my y minus 5 equal to 0, the minus 5 taken to the right will become a plus 5, and therefore y is equal to 5. Then the y plus 3 set equal to 0 means that the plus 3 will go to the right hand side, then y is equal to minus 3. In other words, the y at B will be minus 3 and the y at A will be a positive 5. So the coordinates then for A, where x is 0, y will be 5, and the coordinates of B, where x is 0, y will be minus 3. Now for question C, to find the equation of the tangent to the circle at A, we will first need the gradient of the radius, because the radius is perpendicular to the tangent, and then we can work out the gradient of the tangent as well in order to get to the equation of the tangent. So to determine the gradient of the radius dA, I will take the y of D minus the y of A over the x of D minus the x of A. So doing the substitution then, 1 minus the 5 over 3 minus the 0. 1 minus 5 is minus 4, 3 minus 0 is 3, so the gradient of the radius dA is equal to minus 4 over 3. Then we must keep in mind that the radius is perpendicular to the tangent, and therefore if I multiply their gradients with one another, it must give me -1. So the gradient of the radius dA was worked out, -4/3, times the gradient of the tangent must equal -1. So to get the gradient of the tangent alone, I have to do the opposite calculation of multiplication and divide by the fraction. Therefore, I take the -1 divided by the -4/3, which gives me a +3/4. The short method, change the sign from negative to positive and toss the fraction 3/4. Now I have the gradient of my tangent, and I must remember that the equation of a straight line is y equal to mx plus c. So the m is the gradient, which I can substitute into my straight line equation. Then we've also worked out the coordinate of A, which is a point on the tangent, and therefore I can substitute x with 0 and y with 5 in my standard equation in order to solve C. 3/4 times 0 is 0, and therefore C is equal to 5. Then I write down my standard equation for the tangent, y equal to mx, the 3/4, x plus my c value, the 5. Question D is done in exactly the same manner. First, I determine the gradient of the radius dB by using my gradient formula, and I take the y of D minus the y of B over x of D minus x of B. Then I do my substitution. I took the 1 minus the -3, which becomes a +3. Then at the bottom, the 3 minus the 0 is also substituted. 1 plus 3 is then 4, and 3 minus 0 is 3. So the gradient of the radius dB is 4/3. But we know that the radius and the tangent is perpendicular, and therefore if I take their gradients and multiply it with one another, it must give me -1. So the gradient of the radius, 4/3, times the gradient of the tangent BC must equal -1. To work out the gradient of the tangent BC, I must use the opposite calculation of multiplication and divide by the fraction 4/3. -1 divided by the 4/3 gives me -3/4. The short method to work out the gradient of the tangent is to use the opposite sign. So instead of a plus, I'm using a minus, and I toss the fraction 3/4. Then for the equation of the tangent BC, I use the standard equation of a straight line, y equal to mx plus c. I can then substitute my gradient -3/4 into my standard equation, but I also know that the point B is on this tangent, and therefore I can substitute the x with 0 and the y is substituted with -3. Multiplying the fraction -3/4 by 0 is 0, and therefore C is equal to -3. Then I have to put everything back into my standard equation and substitute the m with my gradient -3/4 and substitute c with my c value of -3. So the equation is y equal to -3/4x minus 3. Then question E, to determine c, we have to solve the equations for line AC and line BC simultaneously. We've worked out the equations of the two tangents, and therefore, since both of them are equal to y, I can also set their right-hand sides equal to one another. So I will take the 3/4x plus 5 equal to the minus 3 over 4x minus 3. Then to get rid of the fractions, I can times each term by 4. 3 over 4x times 4 gives me the 3x. 5 times 4 gives me 20. Minus 3 over 4x times 4 gives me minus 3x. And minus 3 times 4 gives me minus 12. If I then take my minus 3x to the left-hand side, it becomes a plus 3x. And therefore 3x plus 3x is 6x. If I take my 20 to the right-hand side, it becomes minus 20. Minus 12 minus 20 gives me minus 32. To get x alone, I have to divide both sides by 6. 6x divided by 6 is x. Minus 32 divided by 6 gives me a simplified fraction of minus 16 over 3. Then I'm not finished. I have to take this x value and substitute it into any one of my equations to get the corresponding y value. So if I substitute into my first equation the x with minus 16 over 3 and simplify my fractions and then add 5, y is equal to 1. In other words, the coordinate c will be where x is minus 16 over 3, y is equal to 1. That brings us to the end of this lesson, and you may now start with the activity. Let's look at what is expected of you in this activity. Question 1. Determine the equation of the tangent to a, x squared plus y squared equal to 5. In other words, it's a circle where the center is the origin 0, 0. And the tangent is at the point P where x is minus 1 and y is 2. So we will first find the gradient of the radius and use that gradient to determine the gradient of the tangent, which is perpendicular to the radius. Then question B, we have a circle x plus 2 bracket squared plus y minus 3 bracket squared equal to 5. And the tangent is at the point R where x is 1 and y is minus 1. So here we have a circle with a center AB. So we can read off the center by changing the sign to a minus 2 and changing it here to a plus 3 for the y value. So the center here will be where x is minus 2, y is 3. Once again, we will then work out the gradient of the radius and use that gradient to determine the gradient of the tangent. Then question 2, a circle has a center P where x is 1 and y is minus 3 and radius 8. Write an equation for the circle, so we will use the equation of a circle with center AB. Then question B, a point B where x is 1 and y is P lies on the circle. Determine the coordinates of B if P is greater than 0, in other words, if P has a positive value. Then question 2C, determine the equation of the tangent to the circle through B. Question 3, in the diagram we have the center A where x is 1 and y is minus 2. And we also have a point of contact with the tangent where x is minus 2 and y is minus 1. The circle intersects the y-axis at Q. Number 3a, find the equation of the circle. So again, we will use the standard equation of a circle with center AB. Then question B, determine the coordinates of Q, in other words, the y-intercept. So we will make x 0 at that point. And then question 3C, determine the equation of the tangent PT. So we will first work with the gradient of the radius in order to work out the gradient of the tangent because the radius is perpendicular to the tangent. Then the last question, in the diagram, two circles touch externally at the point A where x is 2 and y is 3. O is the center of the one circle and C is the center of the second circle where x is 6 and y is 9. The common tangent AB cuts the x-axis at B. Question A, find the equation of circle C. In other words, we're going to use the standard equation of a circle with center AB. Then question B, the equation of the tangent AB. So we will first work with the radius and find the gradient in order to find the gradient of the tangent to eventually get to the equation of the tangent. Then question 4C, we have to determine the magnitude of angle ABX. In other words, we're going to work with the inclination angle and say that tan theta is equal to the gradient of the tangent AB. Then question 4D, we have to determine the coordinates of B. In other words, where will the tangent cut the x-axis? So we will make the y value 0 in order to find the corresponding x value at that point. You may now start with the activity. First complete it before you listen to the memorandum discussion. Let's look at the solutions of this activity. For question 1a, you had to work out the equation of the tangent. You were given a circle with center, the origin 0, 0, and the tangent touches the circle at the point P where x is minus 1 and y is 2. So therefore, we will first work out the gradient of the radius by taking y of P minus y of O over x of P minus x of O. If we do the substitution then, 2 minus the 0 minus 1 minus the 0. When we simplify, 2 minus 0 is 2, minus 1 minus 0 is minus 1, and 2 divided by minus 1 is minus 2. So the gradient of the radius OP is equal to minus 2. Remember that the radius is perpendicular to the tangent, and therefore we will take their gradients, multiply them with one another to equal minus 1. So the short method is to change the sign from a minus to a plus, and then we toss the fraction and it becomes 1 over 2. So the gradient of the tangent is equal to a half. Then we use the standard equation of a straight line, y equal to mx plus c. We substitute the gradient of the tangent into m. Since the tangent goes through the point P, we can substitute the x with minus 1 and the y with 2. We then simplify the fraction. A half times minus 1 is minus a half. If minus a half is taken to the left, it becomes plus a half, and 2 plus a half is 2.5. Then we substitute back into our original straight line equation, where we said that the gradient of the tangent is a half, and the c value which we've worked out is also substituted as 2.5. So the equation of the tangent is y equal to mx, a half x, plus c, which is 2.5. In question 1b, we were given a circle with the center AB, which we had to read off from the circle equation. And remember, the simplest way is to just use the constant value and change the sign. So where it was x plus 2 bracket squared, we're going to use a minus 2, and where we had y minus 3, we change the sign to a plus 3. So we are using the center Q where x is minus 2 and y is 3. The tangent goes through the point R where x is 1 and y is minus 1, and therefore we have two coordinates of which we can now work out the gradient of the radius. We will take y of Q minus y of R over x of Q minus x of R. Then we do the substitution. 3 minus the minus 1 becomes a plus 1, and minus 2 minus 1 gives me minus 3. So now we have the gradient of the radius QR equal to 4 over minus 3. Now you might be wondering, why did I start with y of q minus y of r and not the other way around? Now it won't make a difference. You may start with y of r minus y of q over x of r minus x of q. If I then substitute, I will have minus 1 minus 3 over 1 minus a minus 2, which becomes a plus 2. If I then simplify, I have minus 4 at the top and positive 3 at the bottom. So it doesn't matter where I put my negative as long as I have a negative sign in front of the fraction. Once again, since the radius is perpendicular to the tangent, when I multiply the two gradients with one another, it must be equal to minus 1. So the short method is to change the sign from negative to positive and then toss my fraction, so the 3 goes to the top and the 4 to the bottom. So the gradient of the tangent is equal to 3 over 4. Then for the equation of the tangent, I use the standard equation of a straight line, y equal to mx plus c. I substitute the gradient m into my standard equation, and then I use the coordinate of r, where x is 1 and y is minus 1, because this is the point where the tangent touches the circle. So I will substitute x then with 1, and y is substituted with minus 1 in order to solve c. 3/4 times 1 remains 3 over 4. If I take it to the left, it becomes minus 3 over 4, and therefore minus 1 minus 3 over 4 is minus 1 and 3 over 4. So the c value of my tangent is minus 1 and 3 over 4. Therefore, I can conclude that the equation of my tangent is y equal to mx 3 over 4x minus the c value of 1 and 3 over 4. In question 2a, I have to determine the equation of the circle with a center at P where x is 1 and y is minus 3. In other words, I'm using the standard equation of a circle with center AB. Therefore, A is then substituted with the 1, and B is substituted with the minus 3, and the minus 3 becomes a plus 3. We were also given the fact that R is equal to 8, and therefore if I substitute R with 8 and I square it, it is equal to 64. In question 2b, we have to determine the value of P when P is positive. In other words, the coordinate of B will be somewhere here in the first quadrant where x is 1 and y has a positive value, not a negative value. So if I then use my standard equation of this circle, which I've already worked out, and I substitute x with the 1, I can simplify in order to solve P. If I then have 1 minus 1, it is 0, and 0 squared is 0. If I square my P plus 3 bracket squared, I will take the P and square it. For the middle term, I take the P multiplied by the 3 and then multiply by the 2, and that gives me 6P. The 3 squared, 3 times 3 is 9. 64 taken to the left hand side becomes minus 64. If I then simplify my constant values, 9 minus 64 is minus 55. Now I have a quadratic trinomial equal to 0, and therefore I can factorize further. P times P gives me the P squared, and 11 times 5 gives me the 55. Then I must test my middle term. 11P minus 5p gives me 6p. And now I can take each bracket and set it equal to 0 separately in order to solve p. If I take my first bracket, p plus 11 equal to 0, the plus 11 will go to the right hand side and become minus 11. If I take my p minus 5 and set it equal to 0, the minus 5 taken to the right will become a plus 5, and therefore p is equal to 5. We can now see that p equal to minus 11 is not applicable because it will be the y value at this point. And we specifically saw that p must be greater than 0. In other words, we use the positive solution of p being equal to 5. So if x is 1, y is 5. Please keep in mind, if you struggle with factorizing a trinomial, you have to go look up grade 9 factorization of trinomials. In question C, we have to determine the equation of the tangent at the point B. Therefore, if I work out the gradient of the radius, I can use these two coordinates and then say that the y of the center minus the y of point B over the x of the center minus the x of point B. When I then substitute, I have minus 3 minus 5, which is minus 8, and over 1 minus 1, which is 0. Now division through 0 is not allowed, and therefore it is undefined. So this is a special case where we can see that the radius is parallel to the y-axis, and therefore the tangent will be parallel to the x-axis. So we can have the conclusion here that the equation of the radius is a special line where x is equal to 1, and the equation of the tangent will also then be a special line where y is equal to 5. In question 3a, we have to determine the equation of the circle, and we were given the center, and we were also given a point on the circumference of the circle. Therefore, if I use my standard equation of a circle with center AB, I can substitute A with 1 and B with minus 2. If I then have minus a minus 2, it becomes a plus 2 inside the bracket. Then I can also substitute the point, which is on the circumference of the circle, in order to solve r squared. I substitute x with the minus 2 and y with the minus 1. Then I simplify to solve r squared. Minus 2 minus 1 is minus 3 squared, which becomes plus 9. Minus 1 plus 2 is 1. 1 squared is 1. And therefore, 9 plus 1 gives me the r squared value equal to 10. So the equation of this circle with center x1 and y minus 2 can then read x minus 1 bracket squared plus y plus 2 bracket squared equal to r squared, which is 10. In question B, I have to determine the coordinates of Q, and it is also the y-intercept of the circle on the positive y-axis. And therefore, at the point Q, I can conclude that x is equal to 0 because it's a y-intercept. If I then substitute x with 0, I can solve the corresponding y value. So 0 minus 1 is minus 1, and minus 1 squared is a positive 1. Then I have my y plus 2 being squared, and if I simplify my bracket squared, I will have the y being squared. For the middle term, I multiply the y with 2 and again by the exponent 2, which is 4y. 2 being squared, 2 times 2 is 4. And my plus 10 taken to the left-hand side becomes minus 10. If I then take my 1 plus 4, I have 5, minus 10, I have minus 5 as the constant value. The y squared stayed like that, and the 4y also stayed like that. Now I have a quadratic trinomial equal to 0, and therefore I can factorize further. Y times y gives me y squared. The factors of 5 is 5 times 1. I test my middle term. Plus 5y minus 1y gives me the 4y in the middle. To solve y, I have to take each bracket and set it equal to 0 separately. So if I take the y plus 5 equal to 0, the plus 5 taken to the right-hand side will give me y equal to minus 5. This solution is not applicable because it's on the negative side of the y-axis, and it was clearly shown that q is on the positive side of the y-axis. If I then take my y minus 1 and set it equal to 0, the minus 1 taken to the right will become a plus 1, and therefore the corresponding y value where x is 0, y is 1. In question C, we have to determine the equation of the tangent. So we will first work out the gradient of the radius AP by taking y of A minus y of P over x of A minus x of P. If I then do my substitution, minus 2 minus the minus 1 becomes a plus 1 over 1 minus the minus 2, which becomes a plus 2. Simplifying, minus 2 plus 1 is minus 1, and 1 plus 2 is 3. We know that the radius is perpendicular to the tangent, and therefore when I multiply their gradients, it must equal minus 1. So the short method is to take the gradient of the radius and use the opposite sign. So instead of a minus, I now use a plus, and then I toss my fraction. The 3 goes to the top and the 1 goes to the bottom, and 3 over 1 is just 3. Then I have my gradient of my tangent being equal to 3, and when I use the standard equation of a straight line, y equal to mx plus c, I can substitute m with 3. We also know that the point P is on the tangent, and therefore I can substitute x with minus 2, and y is substituted with minus 1 in order to solve C. 3 times minus 2 is minus 6. If the minus 6 is taken to the left, it becomes a plus 6, and minus 1 plus 6 gives me the C value equal to 5. And therefore the equation of this tangent is y equal to 3x plus 5. In question 4, we have to determine the equation of the circle once again, and we're given the center where x is 6, y is 9. We were also given a point on the circumference of the circle where x is 2 and y is 3. So I now use my equation of a circle with center AB. A is then substituted with 6 and B is substituted with 9. And then to solve r square, I will substitute the point which is on the circumference of the circle. So the x is then substituted with 2 and the y is substituted with 3. Then I can simplify my brackets. 2 minus 6 is minus 4, and minus 4 squared means that minus 4 times minus 4 is 16. 3 minus 9 is minus 6, and minus 6 squared becomes a positive 36. Adding the two constant values together, 16 plus 36 gives me the r squared value equal to 52. Therefore, I can conclude that the equation of this circle is x minus 6 squared plus y minus 9 in brackets squared equal to r squared, which is 52. In question B, I want to work out the equation of the tangent, and therefore I will start off with the gradient of the radius CA by taking y of C minus y of A over x of C minus x of A. Substituting then, 9 minus 3 at the top over 6 minus 2 at the bottom. 9 minus 3 is 6 and 6 minus 2 is 4. The fraction simplified is 3 over 2. So the gradient of the radius CA is equal to 3 over 2. To work out the gradient of the tangent, I use the opposite sign, so the plus changes to a minus. I toss the fraction, so the gradient becomes 2 over 3. Remember, since the radius is perpendicular to the tangent, when I multiply their gradients, they must equal minus 1. To now work out the equation of the tangent, we know that the tangent is a straight line, and therefore I use the standard form of a straight line, y equal to mx plus c. And then my gradient is substituted with the minus 2 over 3. I also have a point A which is on the tangent, and therefore I will substitute x with the 2 and y is substituted with the 3 in order to solve c. Minus 2 over 3 times 2 is minus 4 over 3. If I take this fraction to the left, it becomes plus 4 over 3, and 3 plus 4 over 3 is then 13 over 3. Therefore, my equation of my tangent is y equal to mx, m being minus 2 over 3, plus the c value, 13 over 3. Question 4c includes a little bit of analytical geometry where we have to work out the inclination angle. Now we already know that the gradient of AB is equal to minus 2 over 3, and therefore I can say that tan theta is equal to the gradient minus 2 over 3. Now remember, when we work out a reference angle, we use shift tan. With only the positive value 2 over 3, we ignore the minus for a reference angle. So if we enter on the calculator, shift tan in the brackets, 2 over 3, close the bracket, press equal, it will give us the reference angle of 33,7. But since we are working with an obtuse angle, we have to subtract the acute angle 33,7 from 180 to determine the obtuse angle being 146,3 degrees. For question D, we have to determine the coordinates of B, and now we already have the equation of the tangent being y equal to minus 2 over 3x plus 13 over 3. And since it is an interception point on the x-axis, we know that y at that point is equal to 0. Therefore, I substitute y with 0 in order to solve x. If I then get rid of the fractions, I can multiply each term by 3. 0 times 3 is 0. Minus 2 over 3x times 3 is minus 2x. And 13 over 3 times 3 is 13. If I then take my minus 2x to the left, it becomes a plus 2x. To get x alone, I have to divide by 2 on both sides. 2x divided by 2 is x, and 13 divided by 2 is 6.5. And therefore, the coordinate of B will be where x is 6.5, y is 0. Now that brings us to the end of this memo discussion, and you may continue with the next lesson.